Hello friends, myself Supran Sharma, faculty member in School of Business, Faculty of Management, श्री माता वैष्णो देवी यूनिवर्सिटी कटरा। आज का हमारा विषय है जिस पे हम बात करने वाले हैं सिंपल लीनियर रिग्रेशन मॉडल, अ फंडामेंटल स्टेप टूवर्ड्स एडवांस रिसर्च टूल्स। सिंपल लीनियर रिग्रेशन मॉडल और मल्टीपल रिग्रेशन मॉडल, both are the two sides of the same coin. If we have one independent variable, it becomes simple linear regression model, and multiple regression model if we have more than one independent variable in the model. In the basic statistics analysis, the role of regression, all of you must have heard during your school times. Correlation, regression were the two tools with which every student was made familiar in the very beginning of the 10th class, 11th class, 12th class, if you have gone through mathematics in the 11th and 12th. Otherwise, in the up to 12th, 10th also, such kind of tools are used. Today, we are going to have deliberation in this field, how it happened, what is the role of it, how it is applicative in nature, किस तरह से इस टूल के साथ डीपर एनालिसिस, एम्पिरिकल एनालिसिस किसी भी विषय पे किया जा सकता है। और इसका इम्पॉर्टेंट डायमेंशन ये है कि सिंपल लीनियर रिग्रेशन मॉडल इज एप्लीकेटिव इन नेचुरल साइंसेस, सोशल साइंसेस, ह्यूमैनिटीज, सोशल साइंसेस डायमेंशंस विच आर कनेक्टेड विद द नेचुरल साइंसेस एवरीवेयर इन अ रिमार्केबल मैनर। और ये एक ऐसा टूल है जो ब्रेड एंड बटर की तरह काम करता है फॉर एन इकोनोमेट्रिशियन, बिकॉज दिस इज द टूल ऑन द बेसिस ऑफ विच द कास्टल of the success of different models, estimations of the different models are being made in the whole world of statistics, mathematics, econometrics and what not. The financial analytics, business analytics, or the whole world of analytics revolves around this basic tool. तो आपको इस tool की different dimension को समझना इतना ही important है जितना important है आपके लिए basic mathematics को समझना। आज हम इस विषय पे बात करने वाले हैं और सबसे पहले हम आपको शुरू करेंगे with some questions which can be answered comfortably with this very regression tool that is known as simple linear regression model. We can also call it OLS. O stand for ordinary, L stand for least and S stands for square. So ordinary least square method is another name you can give to simple linear or multiple linear regression model. So broadly linear regression model or OLS can be called as synonym in that sense. Like the question, why children drop out from school system, what are the reasons behind it, what are the causes behind it. So cause and effect can be assessed through this very regression tool comfortably. Like the question is, why workers go on strike, what are the reasons behind it. So if you want to identify those reasons, you can look to this tool intelligently. Why subordinate rebel against authorities can be answered through this tool. Why indiscipline among the student is rising, among the children is rising. What effects the mass media on the children and youth, what kind of effects are there. We see that today social media's impacts are marvelous, some positive, some negative. We can identify that. Similarly, you can have an answer to the question like, why some people are loyal to same brand and some others are loyal to some other brand. What is this brand loyalty and how it happened? And along with it, the question like brand switching. In the field of management, if I exemplify, why some people switch over from one brand to other, what are the reasons behind it, what are the causes behind it, can be identified through this remarkable tool called regression analysis. Poverty and development, what kind of connections are there? Basic idea, basic frame can be generated through this very tool called regression analysis. Similarly, impact of mobile number portability or insurance portability nowadays you are hearing, what are the reasons behind it, can be very smartly be answered through this. In the same way, the question in front of your screen you may be seeing, how can I know whether there is any relation between the dividend paid by the company and the cash from operating activities? It can be answered in a very lucid way through this remarkable tool. Another question that sometime come in the mind of somebody, can we say that return on a company's share depends on its size and a book value or the market value or the ratio of book value to market value? Is there any connection? Answer can be searched out through this very tool of regression. Can it be empirically proved that companies with larger FIIs, foreign institutional investor holding, pay higher rate of returns to in terms of dividend? Is it true? Answer can be searched through this regression tool. Can we know whether Indian stock markets are becoming more and more volatile over the period of time? Answer can be searched out through the tool of regression. Similarly, are Indian stock market efficient enough to discount our bonus declaration information, or is it going to surprise event for the markets? Can be answered through this tool. So, if you see the variety of questions that you are looking and the similar type of other questions that are coming in your mind can be answered through this tool. So, if you are looking forward to these kind of answers, then you have to enter into the world of what you call the econometric analysis. Econometric analysis, the fundamentals are prepared through this very tool called regression analysis, because it is easy to lie with econometric. At the same time, it is hard to tell truth without it. So, it is sufficient to, these two lines are suffice to understand how powerful and effective this econometric tool of regression analysis is. What is econometrics? Should we understand? The economic measurement is the correct answer of it can be. It is the art of econometrician consists of in finding the set of assumptions that are both sufficiently specific, sufficiently realistic to allow him to take best possible advantage of the data available to them or to him. It is integration of economics, mathematics and statistics for the purpose of providing numerical values. So, this econometric analysis is empowered by the very fundamental tool called regression analysis, and this regression analysis can be understood in the simple form. The simple linear regression analysis can be framed like this, as it is in front of you, where we have one independent variable and one dependent variable, where independent variable is represented by x, where y is reflected as dependent variable. See, y on x means y is dependent variable, it is depending upon x. There are various other terminologies can be given to it, like we can say y is explained variable, where x is explanatory variable. So, there are different terms as per the requirement of the model, research model can be framed, but this fundamental functional relationship is that is in front of your screen. Y as the function of x is the basic equation, basic functional relationship, not equation, that will help you to understand the whole dimension in a very intelligent and a very significant and lucid way. So, if as I was describing you the type of variables in the regression, there can be type of variable called independent variables, like we said y and x relationship, x is an independent variable and y is a dependent variable. Along with it, you can have a terminology called intervening variable. Intervening variable, like you can see the case number 1, in which z is working like an intervening variable. In the another terminology can be antecedent variable. In the antecedent variable, as x is working like antecedent variable to y and z is antecedent to x. Similarly, extraneous variable is another dimension in which z and x is being extraneous to Y, and so on, blah 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 things can be explained, but important thing is these four fundamental phenomena are the basic soul of the tool that we say the regression analysis. And in the advanced research, these number 3 and number 4, the intervening variable and antecedent variables are now gaining lot of respect in the field of empirical research. In the industry as well as in the academia, the role of these two variables are very important. Some other examples through which you can understand the relationship between the dependent and independent variable is in front of your screen in terms of various examples, like consumption and income. Here consumption is a dependent variable depending upon income. So, C is the function of I, as consumption is the function of income. Similarly, if we look into the one-way causation, there is possibility of two-way causations also, but for the time being, for the beginning, in the simple linear regression model, we look to the one-way causation. So, demand and price relationship, demand depends upon price. So, price is an independent variable and demand is a dependent variable. Similarly, wages and education is another relationship. Better the education, better the wages, or better the salary you will be getting. So, wages is the function of education and there is a positive relationship. So, it is also important to understand that simple linear regression model reflects positive as well as negative relationships. So, what kind of relationship is there, whether it is positive or negative, and to what extent it is positive, because there is a plateau you will be getting, after which there may be downward trends. So, these all dimensions are part of the method through which you will be able to assess the relationship, and that method is simple linear regression model. So, or it can be multiple regression model also if there are more than one independent variable, like say consumption is the function of income and your habits, or consumption is the function of income as well as the price level. If price levels are down, you will be interested to have more consumption. So, there can be multiple regression model also, but for the sake of understanding in this lecture, our focus is on simple regression model in which there is only one independent variable. Similarly, we have examples like food and income expenditure. So, if you have more income, then you will be spending more on food also. So, there can be an association. Similarly, mutual funds and GDP. So, if GDP is growing faster, mutual funds will also be growing faster. So, mutual fund is having a functional relationship with gross domestic product. Similarly, consumption, expenditure and income, these two are variable which can be identified connectivity through the simple linear regression model. Similarly, consumption and past saving is also having an association, like we see consumption is high if your past savings are high. Presently, you may not be having a huge income, but your past savings are so significant that you are able to identify those consumption processes, are you able to maintain those consumption processes comfortably. And let us take an example through which we will be understanding the basic structure of it. Here we have taken a example where quantity and price relationship is given, and say quantity means quantity supplied. So, supply price relationship, suppose we are taking Y is representing quantity supplied and price is the price to be charged by the supplier in the market. So, supply price relationship Y as the function of X can be drawn in the form of a scatter diagram like this in front of you. If we draw the relationship between the two, scatter diagram can be drawn like this, but this scatter diagram will not be suffice because it is not giving anything in numeric numbers. Anything to be identified in the numeric number, you have to draw a line that is called regression line, and simple linear regression model help you to identify that. Like you have two lines here, one is line drawn in the blue color, another one is the line drawn in the red color. Both of them are the linear regression lines. Now, which one is the best fit out of the two is a very difficult question to be answered. One regression line is measured on the basis of the OLS and other is measured on the basis of some other tool like say simple linear regression models alternative known as maximum likelihood method. So, two of the method I have estimated two regression line, one is red, another is blue. Which one is the better fit of this scatter diagram? Because scatter diagram is the real picture of the data that we have drawn on the y-axis and x-axis, and on this one dimensional regression graph, the picture is supposed to be understood which is the better fit. For this better fit, one is red line, look, it is a better fit. On the other side, it may be looking that the blue is also better, but out of the two, which one is better fit is to be identified through the tool called regression analysis based ordinary least square method, because ordinary least square method is known as least square because the deviation from the regression line should be lesser for a better representing line, and OLS give you that edge through which you will be able to identify it. So, the econometric procedure of OLS reflects that determination of regressant and regressor should be clear. It should be the number of equation in the model to be identified. Precise mathematical formulation of that is very important, and significant and magnitude of the coefficient is also supposed to be looked out, and along with it the statistical significance level or an econometric assessment of it can be framed through the processes. Just see this explanation of the regression model with respect to consumption and income. Such kind of regression line can be there. It will become econometric when this random term u will be added to it. So, yi is equal to b0 plus b1 xi plus ui, and ui is the random term. Till ui is not there, it is a statistical you say equation, and it become econometric equation when ui is added in it. So, keep this thing in mind for a complete comprehensive model to frame with and estimate with. The role of the random term is also important, that is called also as error term. So, it is a combination of mathematics, statistics and econometrics. So, for the better learning, the role of mathematics, statistics and econometrics should be taken into hand, and instead of yi is equal to b0 plus b1 xi, you should be adding the random term and then estimate the model in a more comprehensive and more empirical way, which will give you more real world analysis and more real world results. Now, the question is, what is this ui? In the end, I am just before comprehending my session, I just want to explain you. There are 5 reasons behind this random term to be added in the regression equation: omitted variables, random human behavior, mathematical errors, error of aggregation and error of measurement. These are the 5 reasons because of which you will be understanding what is the role of the regression equations and what is the role of the random term in it. If you have dependent and independent variable symmetry, then you can have selection of the different regression models accordingly. If the data is metric and if data is non-metric, things will be different in terms of the dependent and independent variables. So, in whole, you can have multiple regressions like this. Logit regression is another dimension when your data in the dependent variable is not metric. Probit model is also possible when data in the dependent variable is not metric. Similarly, non-linear regression is another dimension that can be taken when both the variables are applied in the metric form. On the other side, ANOVA, MANOVA, discriminant analysis and canonical analysis are also tools of offshoots of the regression that are being assessed and applied, where basics are prepared through the regression analysis fundamental tool. Another one in this dimension is the conjoint analysis and structural equation modeling, which is nowadays in huge demand at different structure, different steps. Last but not the least is this table that is being shown to you. If data is metric on the both sides, means dependent and independent variable both are metric, you can apply regression very comfortably and you can have a better analysis. But if your dependent variable is non-metric, right, then things become slightly different, and then you have to apply qualitative response modeling based discriminant analysis or logit analysis, probit, tobit, like that. And if your dependent variable is non-metric, but your independent variable is metric, you can apply your related tools that I have explained you. But if dependent variable is metric and independent variable is non-metric, then you can apply ANOVA and MANOVA. But if both the places non-metric data is available, then conjoint and canonical analysis are 2 examples through which you can frame. So, in the end, in the comprehending the whole analysis, I can explain that if you want to learn the advanced tools, basis should be generated through the simple linear regression model, and once you have understood the simple linear regression model in detail, then these tools become easy to apply. Otherwise, if independently you will be trying these kind of tools without basic knowledge of the OLS, basic theoretical knowledge of the OLS, it will become a challenge to you to understand those dimensions. So with these words, I end up this session with the idea and with the hope that you have enjoyed the session, you will learn through it. Thank you so much.